So it's my pleasure to take us now to the moon, return to the moon. And the moderator is Professor Jeff Hoffman, and I will let Jeff introduce our panelists. Jeff.
Okay, thank you, George. And I don't want to give, we have a limited amount of time and lots to talk about, so we're going to have just very short introductions. Afreen Siddiqi, gosh, you've been here since you were an undergraduate.
Yes.
She's on the research staff of the AeroAstro department, but also teaches courses, and she's taught courses both in technical areas, in policy, and in particular has a great interest in sustainable lunar exploration, which I think we're going to talk about. Forrest Meyen, I was his thesis advisor. He did a great thesis on MOXIE before MOXIE was ever launched. And the chemical analysis really gave us the ability to operate MOXIE successfully and safely. Now he is, he was the co-founder of Lunar Outpost, making rovers for the moon. They had a rover on the moon together, and I'll combine this with introducing Cody Paige, who's the head of the Space Exploration Initiative at the Media Lab, and Cody just got her PhD recently, but Cody was responsible for, I guess, the special camera that was flown and a little micro rover, which were all on Forrest's rover, which in turn were all on the Intuitive Machines lander, which it found, unfortunately, after it landed, the rover was over here and Intuitive Machines fell right on top of the rover. So got to try again. It will be successful. And finally, Lonnie Petersen, who is a professor specializing in human physiology. She's a PhD, MD. And you know, when we go to the moon, we're going to be living for long duration, hopefully at a reduced gravity level. So a lot of interesting physiological things to deal with. So I'm not going to start with questions. What I've asked each of the panelists to do is, you know, the theme is return to the moon. And of course, I'm old enough. I was a graduate student when we went to the moon the first time in Apollo. And, you know, we kept asking questions. Why has it taken so long to get back? Now that we're finally getting ready to go, what are your thoughts about that? So a little elevator speech from each one of them. Afreen, why don't you start on that end?
Sure. So, you know, we're very excited about a new project that we've started here that I'm really going to be highlighting as starting comments. This is a project that has been funded by NASA's Office of Technology Policy and Strategy, and now has been moved over under the supervision of the Director of Space Sustainability at NASA. So I just want to highlight that as we're thinking about sustainability in lunar exploration, it's not just a bunch of us academics trying to find an interesting problem to work on. It's actually of interest to people who are very actively and seriously thinking about going back to the moon, lunar exploration, and so forth. So with that context, I want to highlight that a sustainable presence has been a part of the key sort of objectives for lunar exploration. And the question has been raised that what does sustainability really mean? We talk about sustainability in the context of Earth, usually about, you know, the biosphere, maintaining the biosphere so that it can, you know, provide for human sustenance. Does it mean anything when we're talking about going to the moon? And the answer is absolutely yes, because if you think about sustainability in a very practical, pragmatic way, and if I'm going to use the definition that the United Nations has actually articulated about 3 years ago in 2021, the United Nations Office of Outer Space Affairs, they basically articulated as sustainable space operations are those that enable you to continue to operate in space indefinitely into the future. But they also make a very explicit mention of preserving the space environment. So I'm paraphrasing the definition, but it essentially says that, you know, sustainable space activities are those that enable you to indefinitely operate in space in ways that enable equitable access and benefits to space exploration, and preserving the space environment so that current generations can meet their needs as well as future generations can meet their needs. So that makes a lot of sense. We want to enjoy the benefits that space exploration offers, but how do we do so? By being very explicit and thoughtful as we engage engage in large-scale and extended activities that are now being planned for the moon? And that's a very open question that we don't fully understand, and I think there's a real need for us to really fully interrogate. What are some of the questions that are emerging? Well, the first one, I would say, is one that really impacts all of us, that as we leave Earth to go to the moon, what are the impacts we are creating on Earth? And what are the ethical dimensions, honestly, so to speak, that as space rockets activities engage, sort of expand, the atmospheric implications are borne and felt by everyone. So although some companies or some actors might enjoy the benefits, the costs, so to speak, if there are any from environmental impacts, will be borne by all. So we really need to be understanding this seriously. There's research done by NOAA, a very good paper published just 2 years ago in Proceedings of National Academy of Sciences, taking measurements of the stratosphere and showing elevated levels of metals that can be attributed to rocket reentries. So aluminum, lithium, lead, and copper, they're all in elevated levels in the stratosphere, all directed to sort of rocket reentry. So this is not just hypotheticals. These are things that have actually been measured by taking samples from the stratosphere and then attributing it to elevated activity. So this is a real question. What does that mean for stratospheric pollution? Is that going to create impacts that are going to be harmful? We don't know yet. This is still atmospheric chemistry that needs to be unpacked and resolved, but we do know that these are new levels that actually exceed the natural cosmic influx that the Earth naturally receives of these metals. So that is one, right? The impacts that Earth will feel as the activities expand going into space. And can we be smart about it, right? Can we be sure that we're engaging in this in smart and active ways? And then going on all the way to the lunar surface, the question of sustainability is that can we engage in operations that enable us to explore and engage in the scientific pursuits that actually inspire so many people, right? The moon has been a source of inspiration, perhaps for all humankind. I would say, I like to remind people that the moon is perhaps something that almost all human beings who have lived on this planet have seen. They may not have seen all places on Earth, but every human being has seen the moon, almost every human being. So we have a human connection to that, natural planetary body that is our neighbor, and how do we engage with it in a way that perhaps preserves its special place that it offers for conducting science, for learning about the origins of the solar system and of our own planet. Just to quote, we were talking about the vision for space exploration that was, sort of launched in 2005 when I was a graduate student in the department. And I wish I had read it that time, but it's beautifully written in case anybody's looking for some good bedtime reading. And it basically starts with saying that the moon is a witness to 4.5 billion years of solar system history. That is the best preserved anywhere else in our solar system. So then what does that mean if you want to engage with it in ways that might actually destroy the scientific potential it may have because of activities we may conduct unwittingly, but then later on find that we've either contaminated the surface, we've altered its terrain, or we've created issues that later on we might wish that we had thought of them earlier. That's sort of the defining and motivating piece that we're looking at. We are not taking just a conceptual perspective, but basically coming up with quantitative metrics in which we are relating what is the magnitude and rate of anthropogenic activities on the moon, and how do they compare with the natural processes that take place on the moon, and that will be our starting point for quantitatively estimating environmental impacts, and then using those metrics to potentially compare future exploration architectures that might be designed for the moon. I will stop here. I don't want to take all the time, so I'm sorry I wasn't mindful, but happy to take this conversation.
Well, it was an elevator speech, but it was a tall building, right? Cody, you're head of the Space Exploration Initiative. What are all of you and your colleagues saying about returning to the moon?
So I'll just tie it in first from what Afreen was saying, but I actually also have a background in geology, and so the whole concept of like the surface of the moon being this thing that we want to preserve, and seeing rockets landing and things landing and all this stuff that's going on the surface of the moon, and that piece then is no longer something that we can learn or understand or have science from. So that part really resonates with me. But we've been working on I'll start with the 3D camera that Jeff mentioned. So that was our payload on Forrest's MAP rover with Lunar Outpost. And essentially it was going to be the first LiDAR and RGB combination camera that would take high-resolution images of the lunar surface. And we would be able to use this for scientific application and for astronaut training and to bring people to the moon with us as well. So having very high resolution data of the lunar surface, I think is something that will help us to progress and also to allow people to come with us to the moon. As you say, it's inspirational and people want to see that, and having this high resolution data would be really impactful. So we do think about the sort of near term, what we want to do to explore the moon and how we get more people to be able to see it. But we think about the future of it as well at the Space Exploration Initiative. So we think about, yes, near-term technology, but also about the culture and how we bring all of humanity to space with us. So what does it look like then to bring more of humanity to the moon and return there? So we also had a payload that was called the Humans Disc, and this was a recording from people all around the world speaking in their native languages about what the moon means to them. And like the Voyager record, this was being sent out as a communication about what we think about the moon, but this one was a little more introspective. So we can go back one day and astronauts can pick this up and listen to what people were saying about returning to the moon at this point in time when it's really just starting to happen and we're seeing landers going back and we're seeing this more regular cadence of things. And then my last portion of my elevator pitch is that we're creating a bridge between industry and government. And that's, I think, a really key place for academics to sit. So the 3D camera that we had was a Microsoft Azure Connect. So we had an industry-built camera. They'd spent a lot of money developing this technology, and we were able to use that and then work with NASA to actually prepare it for space and build off of a huge amount of experience that NASA has on these missions, and then bring that again back to industry, where we can then actually bring that to the moon, where years ago, it was only NASA that was getting to send these things, and now academics can actually afford to send things to the moon thanks to Lunar Outpost and companies like that that are taking us to the moon in a way that we never could have done before. So,
I'll share regarding that disc with all of the human voices and everything. That was one of my former graduate students, Meyen, was a prime motivator of that. And she said after the landing, all the other experiments got crushed when the Intuitive Machines lander fell over, but the disk is okay. The idea was to get it to the moon, and it's on the moon, so everybody's happy.
Mission success.
Anyway, Forrest is, as I said, making rovers for the moon.
Yes.
Lots of ideas about return to the moon.
Exactly, yeah. So Lunar Outpost, really our goal as a company is to utilize the moon and the moon's resources for the betterment of humankind. So if you look at our logo, it's actually this yellow orb with a blue swoosh and a red swoosh. Kayla Frang is actually wearing it on her shirt if anyone wants to see what it looks like. And everyone's like, why'd you make the moon yellow? Well, the moon's not yellow. You are on the moon looking at the sun and the orbits of the Earth and Mars. And we really try to take our viewpoint of the moon from that perspective of what can the moon give back to Earth, and also our exploration deeper into outer space. And so that underpins kind of the sustainability of our approach and how we develop platforms to basically democratize access to space by creating reliable, repeatable mobility platforms to enable awesome experiments like the MIT Kinect camera, the MIT Astro Ant. We had 11 different experiments on this mission, including soccer teams and scientific research and all sorts of things. But we utilize this platform so that everyone has an opportunity to explore the moon. And this first example, Lunar Voyage 1, while we ended up on the underside of a lander, we still were able to operate all the way through the surface of the moon, operate in transit, and that proved out this platform that now we can reuse. And we actually have 3 more missions already on the books utilizing this platform, 1 already delivered, and then an additional mission after that. So when we look at sustainability, we want to look at repeatability. We want to look at accessing different ways to access the moon, so not just government funding, but getting groups of people together to kind of share the costs of the mission and lower the cost of exploration for everyone. So that's the quick pitch of Lunar Outpost, is we see the moon as that next step for humanity to enable people to do what they want to do on Earth and throughout the solar system. And we really see this as the beginning of a new phase of the economic sphere of the Earth, where the moon is really going to become our 8th continent. And much like the New World coming into the economic sphere of Europe changed the history of Earth, the moon coming into the economic sphere of the planet Earth is really going to change what we can do as we reach out deeper into the stars.
Yeah, I think the entrance of the moon and becoming a part of the economic sphere of the Earth is something we'll address again. But first, we're talking about humans going back to the moon, which means they're going to be exposed to a different gravity level for extended periods. And we have only 3 days is the longest that any human has been exposed to lunar gravity. Lonnie Petersen does a lot of studies of how the human body reacts to different gravity levels. So,
sure, thank you. Well, segueing off of all these fantastic opportunities, it is a very exciting time seeing the first steps of humans returning to the moon. This is a surprisingly new step for us. We've been to the moon, but only 12 of us, and for very short duration, and didn't study ourselves as much as we may have wanted to. If we were doing it today, we would have done more measurements. So it is a brand new world for us in many senses to send humans back to the moon, and understanding how do we send them there safe, how do we keep them safe while they're up there, how do we maintain human health when they inevitably become disease or experience trauma, how do we then diagnose, treat, and handle those emergencies in space. We have had, as you all know, a human presence in space for more than 25 years, for 25 years consistently. So we do know quite a lot about what happens to the human body, the human physiology, the human function, our performance in space, but we know that from 0G. We've also had humans on Earth for extended periods of time, since longer than we can all remember, and we've studied ourselves on Earth pretty extensively as well. We know a lot about us on Earth. So 1G, pretty familiar, 0G, we know a lot. We know very little between those two gravitational loads. Both the moon and Mars sits there. Specifically, the moon is going to be our next real endeavor. So understanding how we will adapt to moon or lunar gravity is to a large extent an unknown. The things that we're seeing when we send humans to low Earth orbit and keep them there for a while is deterioration of the muscle system, the bones, cardiovascular deconditioning. We see fluid accumulation inside the brain, visual degradation, a lot of things that we are trying to counteract. That is a lot of what my lab is focused on, creating countermeasure development and technology so that we can prevent this from happening. We're basically simulating what gravity does to us right now to keep our physiology safe and healthy. We do not know if lunar gravity is going to be enough to maintain health. So a lot of the efforts that we're doing right now is geared towards, in the event that this is not enough, we don't understand that dose-response relationship, but if it doesn't meet the threshold, how can we then augment that lunar gravity to make sure that the human functions and health are maintained while we colonize this new world and utilize it to its full potential?
I don't know if everybody here is aware of the fact that when the International Space Station was originally designed, it was supposed to have a small animal centrifuge, which the US paid for, the Japanese built, and then we never flew it, which is, I think, a tragedy for the ISS. I mean, we would have had the opportunity to learn much more about partial gravity. In a centrifuge, you can increase your local gravity. So here on the Earth, we can go from 1 and upwards. But if you want to have partial gravity, you have to start with 0 and go up from there. And we missed that opportunity. So I hope we send enough instrumentation to measure human physiology because, if we're going to have sustainable lunar operations, we got to keep people healthy on the moon. We heard Bhavya Lal talk about the necessity of nuclear power, which I firmly believe in, but how is that compatible with sustainable lunar operation? We're going to have areas of the moon which are radioactive. We're going to have spent radioactive fuel. Any comments on that?
Yeah, so that's a very good question. And in fact, we were, as part of our project here at MIT, actively looking at it. I do want to give a shout out to the students who've been working on this project in the department. I see Vanessa here and Haley here, and there are perhaps others who have been looking at different aspects of sustainability. And one such question we raised is that how does nuclear power play into it? This is an open question. We don't have any existing designs that have been actually built and demonstrated for viable operations on the moon. Many of them remain simple concepts. We've actually reached out to companies that have claimed to have designs of nuclear power reactors on the moon, but we've been told that they remain concepts. And it's an open question on how viable it would be. The question of risks is very real, particularly if we are talking about, these risks are rare, but they are there because we must remember that the moon does not have an atmosphere. And it constantly gets bombarded by meteorites. So what would different kinds of impacts do for long-lived structure that we might put on the lunar surface? Of course, nuclear power plants would be built to withstand these kinds of events, but nonetheless, these are open questions about physical impacts. Solar particle events happen routinely. Can they mess up with electrical equipment and thereby lead to cascading failures? All of these are very open questions. So short answer is, we don't know yet. The quick answer is that it's actually a very serious concern because if we end up contaminating the lunar surface with these kinds of events, it can really hamper our activities.
Well, look, talk about contaminating the lunar surface. Forrest, you got one dead rover now. You got 3 rovers ready to go, and hopefully you're going to continue to build rovers. What's going to happen with all of these dead rovers? They have limited lifetimes. Are we just going to, is the moon going to look like a used car lot?
Well, I think it would take a lot of rovers before you'd be able to actually see them from Earth. But I think proper disposal of artifacts like rovers, especially into life, is an important concern. So one of the programs that we are working is developing a lunar terrain vehicle for the NASA Artemis astronauts. And a key consideration for that is decommission at end of life. A major concern for scientists in radio astronomy is errant signals from a zombie rover, any sort of zombie asset kind of transmitting after life. So in our approach and designs for some of these things, and maybe it's not thinking about the physical device where it's at, but you actually do need to kind of disconnect it from power at the end to make sure there's not radio pollution over periods of time. And then I think in long term, we'll find places to basically store assets at the end of life so that they're not interfering with key resources on the lunar surface. Places where you wouldn't want to leave vehicles would be ideal landing sites near places of, near eternal light, or and other high value assets like PSRs where there could potentially be resources at water that you wouldn't want to disturb. So end of life management of vehicles is important to make sure that you're putting them in a place that has the lowest impact for future operations.
Yeah, it's interesting that you mentioned the radio contamination. Certainly on the lunar far side has been identified for many years as an ideal place to do radio astronomy because you're shielded from all the radio emissions from the Earth. And yet we're going to have more and more relay satellites going around the moon. and don't know what sort of exploration is going to be done on the far side. But yeah, that's clearly, the astronomers have had enough trouble here on Earth with all the satellites going around in space now. Be ashamed to do that on the moon. What about for sustainable lunar development and exploration? I mean, one of the critical things for exploration is to bring the knowledge of the new areas that are explored and make them part of human culture. It's the sort of thing that the Space Exploration Initiative you talk about. You know, how can we do that? I mean, that's going to be an important part of exploration. And if people back on Earth don't learn about the moon and the moon doesn't become a part of culture, then we've sort of failed at our exploration.
Yeah, and so that's a great way to bring in how do you involve the public in it? How do you involve more scientists? When we're using this high resolution data, we want to put it into virtual environments and areas that are accessible to the public, areas that are accessible to scientists, to be able to learn more. And there are scientists who would never be involved in something like this, who, if they have access to the information, might come up with something very unique so that we can actually learn more about places like PSRs, or maybe policymakers who might be able to give us consideration of, you know, how do we actually make sure that any payload that's on a rover doesn't fly off and do something that now we can't keep track of it. For instance, the astro ant that we had on the Lunar Outpost rover was, initially we'd thought it would be really fun to have it fly off the side of the rover at the end of the mission, and then it's just on the surface of the moon somewhere. But we can't track it, we wouldn't know where it was, and now we're just creating trash on the lunar surface. So thinking about those things and getting perspectives from all different people, I think is really important. And it's kind of comes back to when we originally had a ton of data from space, from NASA, from Hubble, and we provided, well, NASA provided access to all of this and asked the public if they could answer questions that couldn't otherwise, that maybe NASA scientists didn't have time to answer. So engaging the public for them to look at this data and to be able to engage with it and also feel like they're participating in being on the lunar surface. Because again, with humans, you know, we only had 12 people go. It's not like we're ramping up to have hundreds of people living on the moon in the next 5 years. So to be able to allow a lot more people to go to the moon and be part of that, I think is really important in all of these considerations.
So part of sustainability may eventually come down to commercial activity, because if you can make money somehow on the moon, then you know you don't have to worry about government funding so much. One of the prime things that people talk about in terms of valuable resources on the moon is the potential water in the permanently shadowed regions from which we can get hydrogen and oxygen. On the other hand, the Starship, which is going to take people down to the moon, unless they change their propulsion completely, uses methane and oxygen, which they designed because you get methane on Mars. Do we have a disconnect? I mean, I just, maybe that's too technical for sustainability, but we don't have that carbon on the moon that we have.
Well, you know, I would actually sort of even go back on the question, Jeff, of, you know, whether commercial activities would make for a sustainable presence, because they could actually lead to a very fast degradation of the lunar conditions if we don't have the right, you know, rules and regulations in place, right? And we've kind of seen that play out in many parts where large-scale, you know, sort of unregulated commercial activities took place on Earth. So I'm, you know, at least in our project, we're taking a more sort of holistic perspective on understanding what might be perhaps good rules and regulations that could ensure that we can engage with the moon in ways that enable both, you know, private and government-funded exploration, while making sure that we don't end up degrading the environment. I will very quickly say that the question of, you know, sort of accessing resources on the moon is very poorly understood. We do have the conceptual ideas that we could extract resources and use them, But often enough, there hasn't been enough emphasis that the lunar gravity being much lower than what we have on Earth, a lot of the things once you mobilize will escape the lunar system. And that shouldn't actually be discounted. The solar radiation sort of dissociates molecules, and even when we have current landers that sort of land on the moon, they inject a lot of propellant that some of it has been attributed to have been captured in the permanently shaded sort of regions of the moon, but a lot of it escapes out. So if we're talking about, let's say, extracting oxygen from lunar regolith, that's about 40% by mass. What we're really talking about is mass that might actually leave the lunar system. And what would that do in the long term if we're very serious about large-scale extraction? I don't know if anyone has done that analysis. And so on the Earth, when we're extracting resources and using them, the mass is sort of mobilized within the planet itself, and it's not really leaving, the Earth's, system. But a lot of the resource extraction we're talking about in the moon, we don't know if that matter will remain part of the lunar system. Some of it is explicitly discussed for exploring Mars, let's say. Then we're really talking about material exchange. What does that do to the lunar gravitational field? We already know that it's actually pretty unstable. The mass distribution is not uniform, and the lunar orbits exactly are very unstable. So what would that do to orbiting assets in the moon? We don't know. So things quickly become very, very tricky the minute we start talking about large-scale material extraction. I think it's a lot more complex, and we really need to do a lot more science to actually fully unpack it before we make decisions.
And as far as sustainable human presence on the moon, we've done so much investigation, as you said, Lonnie, in zero-G. What sort of equipment are we going to need on the moon? I mean, things are going to be pretty bare in the first few lunar landings, but hopefully eventually we'll be able to send some scientific equipment. If they said to you, all right, we got to set up a laboratory on the moon now to figure out how to keep people healthy in lunar gravity, what would you want to take with you? What are the most important things?
Sure. So we're definitely back to the early days of spaceflight, where mass reduction is a key component, because we are really early days in the lunar establishing. In the health realm, the task or the allotment that we were given in designing what kind of hospital what are you going to set up? What does that hospital sector look like? It was a box. It was about less than a yard, cubic meters, something like that, just shy of that. The initial estimate was 50 kilograms. It then got reduced down to 30 kilograms. So it's really kind of like when you pack a first aid kit in your car, what do you want in it? And you're very limited in the amount of things you can bring, how much it will weigh. You're also limited in who you get to send. I cannot send my radiologist. I cannot send my surgeon. We will have to have procedures that are operational by not layman, but certainly not the high specialists. We can't move all of mass gen up there, right? So creating a system that is operational by non-highly trained people, and which is still really efficient. And it is a great challenge to be faced with as a medical community, because it increases the requirements list. It forces us to redesign and redevelop. All of that good technology, all those new procedures are directly translatable back to Earth. We can use this in austere environment. We don't all live collectively, all humans, we don't all live this close to mass gen. Several people live far away from access to these high-tech facilities. And so all the development there that we do for space translate beautifully back to austere environments and remote area medicine right here on Earth. We have a large project right now, which is not so much focused on the medical, but establishing the base, the habitat that we're building. We got a contract to develop the interface for the habitat structure, how this interface with the rest of the habitat, the greenhouse, all the locks and the interfaces. And we also have a project inside of that same umbrella that looks really at the habitat. Because we need to keep humans alive and healthy up there. for them to fully be productive, they actually also have to be happy and in a good place. So I say this quite a lot. We need to keep our crew alive, healthy, happy, and thus productive. So creating a habitat which is conducive to performance, this includes proper lighting. It includes just being comfortable in your habitat, and so making sure that we utilize our habitat as an active component in the countermeasure program is a really big aim for us right now, and we have both an ESA contract and a NASA contract in this realm. So lots of considerations in this realm.
The moon, I think everybody's been mentioned something about this, but the moon has been bombarded by asteroids, meteors for billions of years. We know that at least a small percentage of asteroids are metallic and many contain rare earth elements. There may be some valuable mineral deposits in various places around the moon, but we've never really done a full mineralogical survey of the lunar surface to know where these things might be. Any thoughts on how, I mean, we can do some of it from orbit, but some of it we've got to have ground truth.
Yeah, absolutely. I think that's an excellent question and a really exciting one to unpack. What is the composition of the moon, and what are the sort of deposits that might be there, just to understand. There continues to be sort of an evolution of our knowledge. Of course, as most people are aware, the Apollo astronauts were looking at this question, of course, in limited ways. And the final mission even had a trained sort of geologist as part of this. So this is really a question that has long captured our attention. One of the more recent work that has appeared that I'm aware of was just published last year, 2024, journal in Minerals and sort of Geology, Crawford et al. I would quote. They have a very comprehensive overview of the latest knowledge we have of minerals on the moon. And it's fascinating. The common elements, as we have carbon on Earth, is not that common on the moon. And there are these important differences. But what struck me in that report, I would say, is that there has been that keen interest for rare earths, let's say, where people have questioned that rare earth elements, which certainly are of prized, sort of interest, given the technology development here.
And important geopolitically.
Important geopolitically, can the moon offer, solutions? And at least from the best available knowledge that we have, it's a striking graph if you look at the present estimates of rare earths as they exist in Earth, as compared to what we know of on the moon. And it's about 2 orders of magnitude difference. So Australia and China and some other countries, Greenland and other places, actually have 2 orders of magnitude more concentration of these minerals in oxides as compared to what the moon offers. So there's a big difference in terms of the quantities that we can sort of extract, but there might be other elements of interest. But speaking to your point, Jeff, the question is that we still don't know for sure. These are all estimates. These are our best projections based on data we have, but there's a lot more that needs to be done to fully understand this.
And that's a key point for our small rover. So Jeff had mentioned the rover was called MAP, so that stands for Mobile Autonomous Prospecting Platform. So the first rover in our line, the very purpose of that is to go and map these resources, because really, when we think about resources that we discover on the moon, I would much rather harvest resources on the moon to make battery-powered cars or other things than plow over the Amazon rainforest. And so that's how we like to think about exploration, and then working with payload partners that maybe have a cool instrument that can sense those resources to integrate into that and see what we can find.
We only have about a minute left, and I'm going to take a prerogative to share a crazy idea about lunar sustainability, and that is the moon as a potential retirement home for elderly people. and let me tell you, just think, you've seen people walking with canes, with physical limitations, in wheelchairs. those of us who have experienced lunar gravity, even in short bursts on the reduced gravity airplanes, you can actually stand up, you can do normal things. It's not like floating. Floating is great, but you don't want to, for long duration, it's sort of nice to have your feet on the ground, be able to pour a glass of water. And how much money, I mean, you could feel young again. You could get out of your wheelchair, you could walk around. And how much money has humanity spent over our history in the search for eternal youth? So it's a dream. My wife doesn't like the idea. She says, no, you're too far away from your grandchildren. But we have grandchildren out in Oregon. It takes us a full day to get out there to visit them. We have one of those nuclear thermal rockets. We can get to the moon in a day, and it's just a question of time. So that's kind of my crazy dream for lunar sustainability in the long run. I don't know if I'll make it there for retirement, but maybe someday. So we'll see. Anyway, our time is up. I thank our panelists, and I hope you've all enjoyed just a little bit of thinking about the future of what we're going to do on the moon once we go back there to stay.
Thank you.